Ever pondered how mere ones and zeros fuel the digital world around us? It may seem like wizardry, but in truth, it's all down to an ingenious system called binary code. Binary code, at its core, is a system of representing letters, digits, or other characters. This is accomplished using a binary system where only two values, typically 0 and 1, are used. It's a bit like the language of computers, a way for us to communicate with these marvelous machines and for them to communicate with each other. Now you might be wondering why we use binary code of all things. Why not use our regular 10-digit numbering system? The answer lies in the simplicity and efficiency of binary. Computers, at their most basic level, are just circuits that can be switched on or off. These two states, on and off, correspond perfectly to the two digits in binary, 1 for on and 0 for off. So when you type a letter on your keyboard, say A, it gets converted into binary code. This binary code is then processed by your computer's central processing unit, or CPU, and the result is displayed on your screen. All this happens in the blink of an eye, so fast that it seems instantaneous to us. But it's not just letters and numbers that can be represented in binary. Images, sounds, videos, essentially any data that can be digitalized, can be turned into binary code. That beautiful sunset photo you took on your last holiday? It's just a bunch of ones and zeros to your computer. Your favorite song? Again, just ones and zeros. Incredibly, these simple binary digits, or bits, form the foundation of all computing systems. Without binary code, we wouldn't have the digital world we live in today. So the next time you use your smartphone or laptop, spare a thought for the humble ones and zeros working tirelessly behind the scenes. Why do computers use binary code, you ask? Well, it all boils down to simplicity and reliability. You see, at the heart of every computer lies a binary system. It's a language of ones and zeros, or in other words, on and off states. This binary language, simple as it may seem, is incredibly efficient for machines to understand. Now imagine trying to convey a complex piece of information using only two digits. Sounds daunting, right? Yet, this is exactly what binary code does. It's capable of representing any number, letter, or symbol using just ones and zeros. It's a beautifully simple system, yet so versatile. Remember, computers operate on electrical signals, which can either be on, denoted by 1, or off, denoted by 0. And that's why binary code is so reliable. There's less room for errors and misinterpretation. Indeed, binary code's simplicity and reliability make it the perfect language for our machines. But who invented this ingenious system? The history of binary code is quite fascinating, dating back to the 17th century. The system was first described by a German polymath named Gottfried Wilhelm Leibniz. Leibniz was a man of many talents, dabbling in philosophy, mathematics, and logic. It was in his work, Explication de l'arithmétique binaire, published in 1703, where he first introduced the idea of using a number system based solely on zeros and ones. He was inspired by the ancient Chinese text, the I Ching, which used a system of symbols comprising of broken and unbroken lines. Leibniz's binary system was initially overlooked by the scientific community of his time. It wasn't until the early 19th century that his system was rediscovered and found its way into the world of computing. Today, his binary system forms the backbone of virtually all digital technology. Leibniz truly revolutionized the world with his simple yet powerful binary system. You might be surprised at how often binary code pops up in your daily life. Yet, it's essentially the language of our digital world. It's the invisible puppet master behind the scenes making everything tick. Take barcodes, for example. Those black and white lines you see on virtually every product. Yep, they're translated into binary code, allowing quick and accurate data entry and tracking. And how about digital clocks? They too work on a binary system. The time displayed is a binary representation of the hours, minutes, and seconds. Even when you're watching your favorite show on your digital TV, binary code is at play, converting the digital signals into images and sound. Have you ever wondered about the magic behind your music streaming service? It's binary code that turns your favorite songs into digital files that can be streamed anywhere, anytime. So it seems we're all a bit more tech-savvy than we might have thought, with binary code surrounding us every day. Ever wonder how your favorite song is stored digitally? Well, the answer lies in the simplicity and efficiency of binary code. You see, every piece of data, be it a song, a photo, or a document, is ultimately broken down into binary code when it's stored in your computer or any other digital device. These strings of ones and zeros are like the DNA of digital data. They define and carry the information for every pixel of your photos, every note of your music, and every character of your documents. When you open a file, your device interprets the binary code and reconstructs the original data. Just imagine, every time you're jamming to your favorite tune, your device is reading and interpreting millions of binary digits, all in the blink of an eye. So the next time you save a file, spare a thought for the incredible binary code that's working tirelessly behind the scenes. Binary code, then, is the unsung hero that keeps our digital lives running smoothly. But how does binary code tie into programming, you might wonder? Well, it's the backbone of all computing. Programming languages are essentially sophisticated ways to produce binary code that computers can understand. This code is used to write software, create websites, and bring digital experiences to life. Think of it like constructing a building. The blueprint is the programming language, offering detailed instructions on how to build. The binary code is the raw material, the bricks and mortar that bring the blueprint to life. Every function, every command, every line of code you see on your screen boils down to a series of ones and zeros. When programmers write code, they're essentially creating detailed instructions that get translated into binary code. Binary code is the universal language of machines. It's what allows programmers to turn abstract ideas into concrete digital realities. Without binary code, we wouldn't have the vast array of digital tools at our disposal today. What about the internet? How does binary code come into play there? You might be wondering. Well, let's delve into that. The internet, in all its vastness and complexity, relies heavily on binary code. When you think about it, the internet is simply a massive network of computers communicating with each other. And how do they do this? You've guessed it, via binary code. Every bit of data that we send or receive online is converted into binary code. Whether it's a simple text message, a photo, or even this video you're listening to, it's all broken down into ones and zeros before being sent across the internet. This binary data is then reassembled at the other end into the words, images, or sounds that we recognize. So the next time you're scrolling through your social media feed, pause for a moment and marvel at the sheer amount of binary data whizzing around you. So every time you send an email or watch a video online, you're using binary code. Binary code isn't just practical, it's also beautiful. The beauty of binary code lies in its simplicity and symmetry. It's a world of ones and zeros. Yet these two digits become the building blocks of all our digital interactions. Imagine a vast, intricate tapestry woven from only two types of thread. That's binary code. It's an elegant dance of balance and contrast, where everyone needs a zero and every zero a one. Binary code is our modern-day Morse code, sending messages at lightning speed. And this beauty hasn't escaped the notice of artists and designers. They've used binary code to create compelling visual art, intricate jewelry, and even striking architecture. It's inspired music compositions and modern dance choreography. Binary code is a testament to the power of simplicity, showing us that from the most basic elements, complex and beautiful creations can arise. Binary code, then, is not only a practical tool but also a source of artistic inspiration. What does the future hold for binary code? As we look to the horizon, binary code remains a cornerstone of our digital world. Its simplicity and dependability make it indispensable in the evolution of technology. With the rise of quantum computing, binary code may take on new forms, but its essence will remain. Quantum bits or qubits can represent 0, 1, or both at the same time, expanding the possibilities of what binary code can do. In the realm of artificial intelligence and machine learning, binary code is the foundation for algorithms that enable machines to learn and adapt. Whether it's self-driving cars, voice recognition systems, or advanced robotics, binary code is at the core. And let's not forget about data security. Encryption systems heavily rely on binary code to protect our data and privacy. As we move towards a more interconnected world, the importance of binary code in safeguarding our digital lives cannot be overstated. Binary code, the simple yet powerful language of our machines, is here to stay. As we wrap up, let's reflect on what we've learned about binary code. We've explored its intriguing nature, its vital role in computers and the internet, and how it shapes our everyday life. We've delved into its history and its use in data storage and programming. We appreciated its beauty and contemplated its future. These 10 fascinating facts have shown us the incredible power and ubiquity of binary code. So, next time you're using your computer or smartphone, take a moment to appreciate the incredible power of binary code.